Hello, our most developed student. My name is Confident and welcome to our revision guide, and this is focused mainly for your June and November exam preparations, and it is one of the most important revision session that I have ever done. And I will encourage you, if you are serious about getting a good mark on your final exam, this is what you need to go through. So if you're in grade 10 and you're preparing for your final exams, this is the topics that you need to cover for your June exams. And in these topics, this session is only focused on trigonometry. Now, I don't want you to lose me here. Look at what I'm going to show you across. Look at what I'm going to cover. So this is what is going to be covered in your trigonometry, and I want you to pay attention to some of these questions as they come in your final exams. You will find them definitely in your final exams. These are previous papers that I'm taking, and if you can look at the slides that I'll be going through, this is what I want to take you through. And as you can see, they like this kind of question. So I'm going to take you on the strategy or the easiest way on how to approach all these. So these are the slides, previous papers as I've taken them, and I want to show you how to answer them. So stay tuned, watch this video until the end. You need to watch it until the end in order to benefit and understand every strategy that I'm going to be showing you. So don't leave this video until it finishes, and trust me, you will see how easy it is to approach this question. So this is trigonometry. As I said, you are looking at a question that they like asking in your exam. And by the way, if this is your first time that you're coming in contact with this channel, try to become a part of our member of our family. You know, here, this is the 24-minute lesson. I call it the channel for the underdogs, those who are struggling with their mathematics, but they're saying, if you can go and help me study maths, I can get a distinction. So I'm looking for those, the underdogs, who can rise from nothing and they obtain a good mark. So if this is you, subscribe to this channel. All right, so let's look at this, understanding the Cartesian plane. So let me lay a bit of foundation here, and that the foundation that I'm going to lay, it is going to be very helpful for you to understand what we are learning about here. So this is a Cartesian plane, and in this Cartesian plane, you have got 0. You saw after 0 is 90 degrees. After 90 degrees, you have 180 degrees. You need to know about this one. And then you've got 270 degrees. And then when you go back, it's 360 degrees. So you see the rotation is, we call this anti-clockwise, because you are opposing the clock. You see this? So you need to identify, you need to be able to kind of have a sketch on this. And then we call them quadrants. So the first one here, we call this the first quadrant, and this one is called the second quadrant, and this is called the third quadrant, and this is called the fourth quadrant. So you divide it into 4 parts. And then when you have divided into 4 parts, what you need to remind yourself also is, remember, this is our x and y in a way. So this is your x, this is also your y. But now ignore the y part and the x part for now, but I want you to focus then on saying, if I am to draw lines here, let me look at this. If I'm to draw a line here and I am to mark that line, now remember, in coordinates you start with x as well as y. You see that? So this is x and y. And now what is the x and the y? The x is this value that is down here. So that is the x value where you are taking it. And the y is this value that I'm taking here. See that? And that is the y value. So the coordinates become x and y. So they will ask you, what is this distance r? This distance r is found by using the Pythagoras theorem. So what you say is r squared is equal to x squared plus y squared. Remember, this is a 90 degrees, so you use the theorem of Pythagoras. So remember that part. All right. it is always positive. Now, what about the other side? If I'm to draw now the same line, let me make it thicker on this side, the second quadrant. Now, look at this line. There is a line on the second quadrant. Again, I want to make that line here. If I'm to use the coordinates, look at this now. I have, if I go down here like this, right, and I go also on that part. Look at this. If I'm to do the quadrant, this is negative x now. So you have got negative x and y is what? And y is positive. See that? But don't forget, r is always positive. What is r? R squared is equal to negative x squared. You see, that will become positive if you say negative x squared plus y squared. Again, if I'm to have my other point here, as I said, I'm just laying a good foundation. That is now on quadrant number 3. You see, now on quadrant number 3, look at something also unique here. You have your x being negative and you have your y also being negative. So this is your negative y. So if I say what are the coordinates, it's negative x as well as negative y. I think that. But don't forget, r is always positive y. R squared is equal to negative x squared, which will become positive, plus negative y squared, which will also become what? Which will also become positive. So you see, that is the part that they'll be looking or trying to see if ever you understand this. And then lastly, we are in the fourth quadrant, and in the fourth quadrant you will have it like that. Let me make it like that in the fourth quadrant. And with the fourth quadrant, look at what you have also. You have here your x, and then you have here your y. So if I say, what are the coordinates? X is positive, and y is what? Is negative y. See that? Again, your r is positive, so r squared is equal to x squared here, plus negative y squared. But it will always be positive. So this is the Cartesian plane that I wanted to bring, and these are very, 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 very important. Now, as we have done this, they usually are going to ask you about these two quadrants. For example, in quadrant number 1, what are we going to say? It starts from 0. See, where from 0 is less than or equal to what? Let's call it theta. If this angle was theta, let's call this angle theta. Alright, so this is how you start the angle. Remember, I said you start from 0 here. Now, if you want to make for quadrant 2, you start from 0 into that. That is now your theta. And then for quadrant 3, you also start from 0. You go all the way to that part. That is your theta. And then for quadrant 4, similarly, you start from 0. You move all the way up to that line. So that becomes your theta. Alright, so for quadrant 1, what you have is theta is less than 0, which is less than or equal to 90, because you are moving from 0 to 90. But for quadrant 2, look at this. We are starting from 0 is less than or equal to theta, which is less than or equal to 180 degrees. Are you with me? And then from quadrant number 3, you can see that you are moving from 0 is less than or equal to x. X is less than or equal to what? 270 degrees. See that? And then lastly, in quadrant number 4, is 0 is less than or equal to x, theta, which is less than or equal to 360 degrees. I was supposed to say theta instead of x there. So that is what you are having, and these are very, very important, and I'll also bring in a few things depending on the questions. So let's look at this question. For example, laying the foundation says you are given that what? 17 sine theta plus 8 is equal to 0, and 90 is less than or equal to theta is less than or equal to 270. So what are they saying there? Determine with the aid of a diagram and without the use of a calculator the value of that. Now they gave you this region here to say this is the value of theta is what? Between 90 and 270. So you come here and say, okay, where is my theta? My theta is starting from what? From 90. And where is it ending? In 270. So they are looking at these two quadrants. See? Which is quadrant what? Which is quadrant 2 and quadrant 3. So remember that. So whenever they're giving you this, we call it the domain or the region where they want you to look for the answer, you need to identify that answer. For example, if they are saying here, they say 90 is less than or equal to theta is less than or equal to 270. When they do this, you ask yourself, where is 90? There is 90. Where is 270? There is 270. What is formed between these? You can see it's two quadrants, quadrants 2 and quadrants 3. That's what I'm trying to say. Alright, so having done that, let me take back and remove that. Alright, so now let's move on. I want us to look at the question now. Okay, it says, given this, and you are given that what theta is in that region, determined with the aid of a diagram and without the use of a calculator. That. So let's write this. 17 sine theta plus 8 is equal to 0. So what they gave us is 17 sin theta plus 8 is equal to 0. Now pay attention. I need to solve for theta. How do you solve for theta? This plus 8 will jump. It's positive. When it jumps the sign, it will become negative. So 17 sin theta is equal to positive to negative 8. Then after that, I need to get rid of that 17. Remember, it's multiplying. So opposite of multiplication is divide both sides by 17. So I'm dividing there. When I have got sin theta is equal to, look, it's minus 8 over 17. This negative doesn't belong to 8. No. For now, leave it like that. It will tell you where it belongs. Just leave it like that and say it's equal to minus. It can belong to 8. It can belong to 17. Now, that's where we come to what we call trig ratios. Let me do this and do another line. Let me do this about trig ratios. When we talk about trig ratios, these you need also to understand. Now remember that word SOHCAHTOA. Remember the word SOHCAHTOA? What does it say? It says sin theta is equal to opposite over hypotenuse, and then here it says cos theta is equal to adjacent over hypotenuse. And what about tan? It says tan theta is equal to opposite over adjacent. Remember this SOHCAHTOA. Now you need to know about the SOHCAHTOA, because what it means is you must know opposite is represented by y and hypotenuse is represented by r, and then adjacent is represented by x and hypotenuse is represented by r in terms of x, y, and r. And then opposite here it's y, adjacent here it's x. Where am I getting it from? The x, y, and r are the ones that we're talking about here to say, remember, there is the x, y, and the r is the long one. So if I'm saying to you, you need to express cos sine in terms of x, y, and r, this is what I'm saying. You'll be given that this is a 90 degrees. So I'm saying this becomes horizontal is your x, vertical is your y, and r is the hypotenuse. Are you with me? Hence, if we put here and say this is theta, then this becomes x, y, and r. Are you with me? So with that, then you will know that here sine theta opposite, which is y over r. What about cos? It's x over r. What about tan, which is y over x? Very important things to know. I'll put here NP. Very, very, very important for you to understand that foundation. Okay, then when you have done that, that question now is easier to solve. Then when you have done this, the question here says, okay, before we go to the question, once you can identify this, you will then be able to tell, now sine theta, we come here to say it's y over r, so this becomes my y, this becomes my r. Where am I getting it from? I'm getting it from there. So which means if I can say r squared is equal to x squared plus y squared, as I said previously, remember we wrote it, r squared is x squared plus y squared. You need then to what? To find your r. So r squared is equal to x squared, which we don't know. Actually, in this case, we are already given r. What is r? R will be 17 squared. Always put brackets. Is equal to x squared. We don't know x squared plus y squared. Now, we said in this case, r is always positive. So, which means here, y is the one that is what? Negative 8 squared. Are you seeing that? So, how do you find x squared? If we simplify, then this what I have here will be 17 squared is what? 289. And then 8 squared is 64. So if you say negative 8 squared is 64, and then again 17 squared is what? Is 289. So if you're going to say 289 is equal to x squared plus 64. See that? Then you take 64 to join that side is 289 minus 64 is equal to x squared. Do you see that? Then you subtract the 2 so that it can give you, but remember we are still finding what? We are still looking for x squared. So it will be 289 minus 64 and then it gives us 225. So 225 is equal to x squared. Now how do I find x? For me to find x, I square root. But don't forget now, the moment you say square root here, you must say plus or minus. Very important, okay? So what you're gonna have equal to x is equal to, now what is the square root of 225? It is 15. So it is, the answer there is plus or minus 15. Leave it like that. Then you need to find out, is it the positive one or is the negative one? Then you come back here to say, remember they are saying sin theta is negative 8 over 17, and we said y is the one that is negative. As you remember here, that's where y is negative. You come back to the cast diagram and you look at the part where y is negative, and they told you, remember our diagram is in 2 quadrants. Let's go back. It's between the second and the third quadrant. So it's between second and third, and look, in the third quadrant here you have a negative y. So let me just remind you again of the third quadrant. It was a minus x minus y. So I'm going to sketch it here on the third quadrant, just a quick sketch, and then we had a line here like this, and then we're saying here x is negative, so it's negative x, and here it's negative y. So the coordinates are minus x minus y. See that? So now it's already telling you y is negative, and we know y is minus 8, and x cannot be positive because it's telling you also x will be negative. So here you have to choose now between plus 15 and minus 15. You can say therefore x is equal to negative 15. I think that you don't take the positive one. Why? Because it's on the what? It's on the third quadrant. That's where y is negative. If you wanted to say, what about this quadrant, the second quadrant? Look at the second quadrant. Let's say I wanted to choose the second quadrant as my answer. And what is wrong with choosing the second quadrant as my answer? Look at this. If this, I make it like that. Look at y and look at x. So y here is positive, is on top, and x is negative x. But I know from my simplification here of negative 8 over 17, y is negative, as you saw, because x is always positive. I mean r is always positive. So r was 17, it was always positive. So the negative sign here could only belong to y. So if y is negative, then I cannot have my diagram here. It's not possible. The diagram can only be in the third quadrant, and in the third quadrant, that's where x is negative. So that's how you kind of solve this part. As I said, I'm laying a foundation here that will help you solve these questions. Now let's look at the questions now. They say find the value of what? How many marks? Okay, I don't have the marks here. Cos squared theta. This becomes easier now. When you've got this, it's easy to find cos squared theta. So you write and say cos squared theta is equal to, now cos squared theta, you write it like this, cos theta, and you put a square. That's what it means. And then you say equal to, now cos theta square is same as cos theta times cos theta. That's what you do. Then what is cos? You come back and remind yourself of the what? SOHCAHTOA. Cos is adjacent of our hypotenuse, which is x over r. See that? That's your cos, x over r. So here you're going to say x over r times x over r. Now what is x? X is negative 15. And then you know what is r. R was what? We did find r. They told us r was 17 there. So there it is, over 17 times, again, negative 15 over 17. And then you get the answer there. Your calculator can then do the simplification here. Alright. So it's negative 15 over 17 times, you can put that bracket again, negative 15 over 17. What is the answer? 225 over 289. So it's 225, it's positive, over 289. So that is the answer there. Alright, then the other one, what are they looking for? They are looking for 2tan theta minus cosec theta. 2tan theta minus cosec theta. Let me write that. 2tan theta minus cosec theta. So what do you do there? You ask yourself, what is tan and what is cosec? So you say 2, now tan, okay, let me write it first like that. 2tan theta minus now cosec. Remember, these are inverses. Cosec is 1 over sine. So you say 1 over sine theta. Alright. Okay, now 2tan, 2, you ask yourself, what is tan in terms of the SOHCAHTOA? You come here and say tan is opposite of adjacent, which is y over x. So you come here and say, okay, tan is y over x minus, now cosec. If sine, this is what you also remind yourself here, the inverses. If sine, remember it's linked with sine, so if sine theta in terms of x, y, and r, sine theta was what? Is y over r. See, sine theta is y over r, and therefore cosec is the inverse, which is equal to, cosec theta is equal to what? R over y. You just interchange that. Alright, so if the other one is y over r, cosec is the inverse, which is r over y. So here you can just look at it and say, this is same as saying 1 over sine theta in a way, but you just do the inverse, which is minus r over y in this case. And then which is equal to 2. Now what is y over x? And then we said here our x was minus 15, our y was minus 8. Remember, y is minus 8, x is minus 15. So it's minus 8 over minus 15. Then minus r is 17 over y. This negative, leave it like that, and there is another negative for y. Y was negative 8. So you just need to be careful there. Alright, then let the calculator do the rest. In this case, for simplifying. Are you with me? So that's how you will then be able to get your final answer. So it will be 2 there's 2 negatives there. Negative 8 over negative 15. Close it, minus, again it's 17 over negative 8. Alright, So I think here I need to put that bracket here so that I can have two brackets like that. Still fine, which is 283 over 120. 283 over 120. You can simplify it in decimals, it's still fine to leave your answer into decimal, but usually it's fine to leave your answer like that. So guys, this is what I wanted to lay as the foundation. Okay, the foundation is here, that's why I called it the example. Now in the next questions, I'll be able now to use the foundation that I was laying so that you can be able now to do all these other questions without a problem. You'll see how easy if you can repeat the first lesson, repeat it again and again, and then now you'll be able to answer these questions that I'm going to be doing in the next lesson. So you can see all these questions, it's good marks that you can score without any problem. So join me in the next lesson now when I start going through these other questions or other examples from the past papers. We have come to the end of our lesson. Remember, as I said, if you're not a part of the family, join the 24-minute lesson. The 24-minute lesson is the channel that is designed with you in mind, and it is for someone, it's not for the brilliant guy who says, I already know my maths, I don't have a problem. It is for the guy who says, you know what, I'm struggling with my maths, I'm having a difficult time, it's stressing me, it's affecting me, it's actually giving me poor quality in life. I'm always stressed, I'm always worried, but I believe if I can get enough learning, enough guidance, I can actually get a distinction. I'm looking for you. You are my student, and I'm ready to guide you and take you across to your distinctions. But you need to be subscribed. If you're not subscribed, then you're not going to be notified every time I'm posting a new video. So let me tutor you, let me teach you, and then trust me, you will not regret this. This is for your June and November preparation. Join me in the next lesson. Thank you.